When people think about geometry, they generally think about proofs. So here in this last task, we're going to get to the heart of what geometry is all about. So by the end of this, you should be able to use properties to justify steps and prove mathematical statements. So first of all, what is a proof? Well, a proof is just an argument, but it's a very rigorous argument that uses logic, definitions, properties, and previously proven statements to show that a conclusion is true. And if it's a good proof, then it's absolute. You can't make a counter-argument because you've proven what it is to be true. And what makes it so rigorous is that this important part of writing proofs is giving justifications to show that every step is valid. And so you're not just jumping from one thing to the next without reason, you're providing a reason for every step in the process. And that's how you know that the conclusion is true. So we're going to start with a pretty simple proof of why, when you have the equation 4m minus 8 equals negative 12, m is going to equal negative 1. But before we get to the steps and the justifications, we need to review some properties. So on the next page, you see a bunch of properties, and it looks complicated, but most of these are actually quite straightforward. So this first box is properties of equality, and we have the addition property of equality. All this says is if you have an equation, such as a equals b, and you add the same number on both sides plus c, then you still have an equation. It's the two sides are still equal. Okay, you've done this before when solving equations, but now we're just giving a name to it. Similarly, the subtraction property says if you have an equation, you can subtract the same number from both sides, and it's still true. Same with multiplication. You can multiply both sides of an equation by c, and it's still equal. Same with division. You can divide both sides of an equation by c, and it's still equal, as long as, of course, your c is not 0, because division by 0 is not allowed. Now, this is a weird one. The reflexive property of equality says that a equals a. That's very obvious, but that's why proofs are so rigorous, is that even the smallest things like something being equal to itself has a name and can be used to justify an argument. Then we have the symmetric property of equality. I'm sure you've seen this before. If you have a equals b, then you can switch it around and say that b must equal a as well. The transitive property is a little more complicated. It says if a equals b and b equals c, then a must also equal c, which makes sense if you think about it. And then finally, another one that you've, I'm sure, used before is the substitution property of equality. If a equals b, then you can substitute b for a in any expression. Now, very analogous to the properties of equality are properties of congruence. And we focus just on 3 of those, and it's the same 3 you saw before, but now we're talking about congruence, which is this fancy symbol there. It's an equal sign with the tilde on top, which just means in geometry that 2 things are not equal, but they're the same shape and size. And so that's where this concept of congruence comes in geometry. So the reflexive property just says that any shape is congruent to itself. So in this example, if we have a line segment EF, well, it's congruent to itself, which is pretty obvious. And then the symmetric property of congruence. If we have an angle 1 and it's congruent to angle 2, well then angle 2 is congruent to angle 1. Again, fairly obvious. And then similarly, the transitive property. If we have a line segment PQ and it's congruent to a line segment RS, meaning the same length, and RS is congruent to another line segment TU, well, PQ and TU are also congruent to each other. Again, pretty obvious, but now it has a name, so we can reference it in our arguments. So, now that we have these properties, we can go back to page 1 and look at that first example, writing a justification for each step of solving this equation. So, the equation is given, and so we just start with the word given. That's what we're given, the equation. Then what happens? You see here we add 8 on both sides in order to cancel the minus 8. This is a basic principle of solving equations. But now we have a name for it. This is the addition property of equality. And I'm just going to abbreviate equality with an equal sign. Okay, we are allowed to do this because of that property. Now there's something that's not a property here for the justification. When we add 8 to negative 12, we get negative 4. And so that is just called simplifying. So I'm just going to write simplify as the justification for that step. And then to get rid of the 4 in front of the m, we divide both sides by 4 because that's the opposite or inverse of multiplying by 4. So those 4's cancel. And the reason we can do this is the division property of equality. And then again, on the right side, when we have negative 4 divided by 4, we get negative 1, and that is just called simplifying. And so we have shown very rigorously by citing these properties why m equals negative 1 if we start with the equation 4m minus 8 equals negative 12. And congratulations, if you haven't done something like this before, you have just completed your first proof. And now we'll look at another one that's more of a geometric proof in the next video.